Hello, how are you, beautiful people? It is me. It is Ms.Fixit, the Fixit gal. I'm here. And today we shall discuss, we're going to touch on simple Ecmp and simple failover in OSPF. So the whole concept of this video here is going to, let me just get rid of my tabs. There we go. The whole concept here today is to zoom in, demonstrate, well, a couple of ways that we can use two links here, just in OSPF. I'm not getting into MPLS yet. MPLS is going to be an entirely different series of events, okay? So in here, we're going to discuss how to load balance across these links, and we're going to discuss how to use one as a failover, okay? So what I've got done here, and by the way, if my microphone sounds weird and lip smacky and stuff, I'm still working out some kinks and trying some different stuff in my home studio here to try to improve things. And I dug out my old stage mic, which is a Ive RE510 stage condenser, which actually has a pretty decent sound to it. So I've got it hot glued to a bottle so I can use it as a stand for the microphone, because I don't have a mic stand for this type of mic. And I've got some foam resting on top of it to try to get rid of the resonant boom that's within the room itself. And I'd like to thank one of our sponsors for getting us a bunch of sound isolating foam for the ceiling in this room. We're actually I'm building a studio in my apartment, which is pretty cool. All right, so back to the point at hand. Let's see here. So we've got router 1 and router 2, as you can see here, okay? We've got two parallel links. So let's bring these up and I'll demonstrate and explain. Okay, let's see if I can make Windows work with me here, because Windows is such a pain in the arse to do anything with. Oh, I say that, but I'm not a Mac user. Oh no, Mac is terrible too. I prefer Linux, and not because I'm being a Linux snob, but because a lot of limitations I find in these simplified operating systems go away when I'm using Linux. All right, so looking at this here, we've got our two routers. Okay, we've got our interfaces here. Okay, God, I'm thirsty. I struggled all day to prepare this video for you guys. Okay, so as you can see, we've got port 5, port 5, port 4, and port 4. It's just as simple as that, okay? Now, if we go under the OSPF's already prepped in here. I demonstrated that in my OSPF video, which is present on the Patreon account. Let's see here. We're going to go to routing, OSPF. Okay. Now, if you look in here, I'm going to show you on both of these guys here. With Ecmp across a link occurs simply when the path cost on the two interfaces is the same. It's pretty much that simple. So you see here we've got 4 and 5 and 4 and 5. So if you look over here, I've got these backwards, by the way. Router 1's on the right, router 2's on the left. That's triggering me. Okay, so if you look here, you're to see the cost and priority are identical on those guys. That means that the traffic is going to balance out across both those links in essence. But in this, we're in a lab, okay? So when you're in a lab, this is a perfectly sterile environment, which means that the two interfaces are completely equal. They are identical in every way, shape, and form, okay? So now that I've said that, the reason why I bring it up is because if you try to do Ecmp, just simple Ecmp, across two links just like this, and the two links are different, you're going to max out at 2 times the capacity of the smallest link. So if your failover link is 300 megabits per second and your primary link is 1 gig, then the maximum that you're going to be able to do with Ecmp just in this manner is going to hit around 600 megs, okay? So that's kind of a fault here. And so now let's go into how you can fix that. So one of the ways that you can fix that actually is by VLANs, and I think that Kevin Myers did a really wicked explanation and demonstration on his channel, which is, by the way, accessible. If you go to the main page of my YouTube channel, you'll see all these other channels that are linked in there, and I think his is Stub Area 51 or Sub Area 51 or something, but he did a demonstration on how to do load balancing using multiple VLANs across the two interfaces. So essentially what you would do here is on the smaller interface, you would have less VLANs. And on the larger interface, you would have more VLANs. And that kind of it kind of defeats the whatever algorithm you're using at the time, whether you're using BGP or OSPF or whatever. Or actually, this even works on layer 2 too. It starts adding more traffic, like more weight to the higher capacity interfaces, the more VLANs you put on it. So you're actually utilizing the VLANs as your transit, and you're actually using the physical interface itself as your transport, meaning that all the data is actually encapsulated within the VLANs and not actually on the interface itself. So I'm not going to demonstrate that in this video, and if you really want to learn more about that, go check out Kevin's channel, and it's got it on there, okay? So going back to this now. let's just look at this. This is a basic demonstration of ECMP. Okay, so you look here, cost and priority are identical. Okay, these are identical. I'll pull up 4 on this side. See? They are identical. So essentially it's as simple as this. Tools, bandwidth test. Let's do a bandwidth test. 10.255.255.1. Okay, and we will do a both test, and I will just start this. Now if we watch the traffic up here, you should see both the links occupied as the data moves across the link. And the routers just kind of make a decision on what traffic's gonna go where. Just like that. It's kind of neat, eh? See that? So it looks like the transmit is moving across one interface and the receive is going across another. So let's do a receive test on this. Okay, so you can see that the traffic is primarily utilizing one interface. Okay, and I'm just gonna put on random data here. Now this is also a little bit more difficult to demonstrate in GNS3 because I'm using CHR instances in GNS3 which are limited to 1 meg per interface. So it kind of janks things up when I'm trying to demonstrate this for you. Okay, let's do a send. Just for the sake of science, okay? There we go. See that? All right, cool. Then did you notice that it's actually sending on R5 and it's receiving? I just wanted to analyze this characteristics. I thought that was really cool that it wants to move the traffic in that direction. Kind of neat, eh? All right. All right, an afterthought that's being spliced in, by the way, was something that my mentor decided to point out before I released the video, which is why my videos get reviewed before I release them out into the world. So this is going to be spliced in somewhere in the video. I just admitted that. I really don't care. It takes a lot of work to make these. So something I want to show you is that with ECMP active, look, I'm going to disable one of these routes just for shits and gigs, so watch. Now, see the routing table here and here? Do you see how there's only one route in here? Watch, when I re-enable the second path with the same cost weight, watch what'll happen in the routing table, how it changes. See, now it's got 2 gateways on this IP. See? That is representation of the ECMP active. Right there. Neat, eh? There's your ECMP running. See? Boop, boop. Let's turn it off again. Watch. Watch the routes change. Now they're 2 separate routes. See? Turn it back on. When it reconverges. And here it comes. Come on. There you go. There you go. So you can see there's 2 gateways for that destination subnet. Cool, eh? Well, destination IP. Yeah, that's all I really wanted to show you. All right, back to the video wherever after this gets spliced in. So now that I've demonstrated that, let's change things up just a little tiny bit. So we're going to call this interface here P4. So this is router 2 port 4. Let's call it the AirFiber 24. Okay, just because I don't play favorites to any one vendor, except I kind of love MikroTik. But I try to work with specifically what you guys easily have access to and work with. And predominantly, you guys are using a lot of MikroTik and Ubiquiti. All right, let's call this one a B5, just to give Mimosa some credit here. Here we go, so we'll go B5. Work with me, brain. 6 hours in preparation for this. That's what ADHD does to you. Okay, so now we've got our 2 links. So I think you know what I'm getting at here. We want interface 5, the B5, the Mimosa B5C, to become the failover for the AirFiber 24. So we want the traffic to primarily utilize the AirFiber 24 interface, which, by the way, could be any other vulnerable type of technology, like, I don't know, a 60 gig interface, or maybe an 80 gig interface, or maybe you're one of those lucky few who have gotten into the terahertz ranges and you're running at like, what, 150 terahertz or something like ridiculous like that, where you're starting to pierce time and space itself. I don't know, go look it up. Go look it up, this is a real thing, by the way. These are experiments. All right, how do we prioritize a link? Well, Ethernet 4 here, we want it to be the higher priority link, right? So I'm gonna bring it up on both sides. All we really need to do is lower the path cost, like so, both sides. Once you lower the path cost here, the traffic is going to be told by OSPF to favor the lowest cost path. It really is that simple. So now the traffic is going to be moving across there. So let's do another bandwidth test here now. All right, so let's do a both test. And hopefully GNS3 doesn't cause issues here. Now you see how all the traffic is moving across the Fiber 24 link, like so. Okay. All of the traffic is moving across that link. Now what happens if that link fails? Well, let's find out. I'm going to kill this link in the middle of the test. Now watch. Oh, did I just kill my own connection? Maybe not. Make a liar out of me, you pile of dog. Oh, you know what? I see what's happening. This is a problem with the CHR instances on GNS3. Because if you look here, you'll see that it's still showing that that link is active right there, even though it's not. And this is because of the virtualization, so it might be a little bit difficult for me to demonstrate. So what I'll do here is I'm going to disable this interface like so. Okay. So now that I've demonstrated, let me just start this again. Nope, as you can see, it wants to be difficult. See, look over here. See how I've got this interface P4 turned off? It's still showing as running over here. It's kind of irritating. So if I turn this back on, though, the funny thing is that, there we go. This router is still seeing it as active, even though that the interface is offline. So, it's a lot of fun when you're trying to lab things, GNS guys, when your stuff doesn't function the way that it's supposed to in the real world. Makes labbing stuff a little difficult. Alright, I've demonstrated this. Now here's something else which you should note too. So this is just my personal preference. Learn OSPF. So we want to change the way that the link behaves so that these guys can fail. Okay, for active failover. So something critical to keep in mind, and I don't have an Fiber 24 that I would be able to demonstrate this on, or any other radio, but there is something called carrier drop detection. It can be called various different things depending on the platform that you're using, but typically it's called carrier drop detection. Now, what carrier drop detection is that you can set a parameter to say when the throughput capacity, like when the actual capability of the link itself drops to a certain point, I'm going to turn off my Ethernet interface. So this is perfect when you're using vulnerable links, okay? So if you don't enable that, what can happen is that you can have a link like an Fiber 24, and it will falter all the way down to, say, let's say that you're used to running 400 or 500 megs over it just out of shits and giggles, right? Now, let's say that a bad storm comes in and it's consistent rain over a long period of times, right? So what'll happen is your link now drops down to like 60 megs. That's not quite enough to cause the link to drop completely. So what happens? The OSPF doesn't fail over. Now, what kind of characteristic you'll see? I just felt something walk past me. What was that? Oh, it's the bunny. Hey, bunny. What'll actually happen is that it'll favor that link still because the link is still active, right? It's not smart enough to fail that. So what you can actually do is enable the carrier drop detection and set it so that if it drops below a certain threshold, like 250 megs, it'll just turn off the Ethernet interface on that radio. When it does that, it causes a hard cut to the connection. The OSPF immediately fails within its constraints, of course, and then all the traffic is forced to go down the other link because your routers are just like, oh, there's no adjacency on that link anymore. Okay, I'm just going to go down the other link. Now, let me show you something here. Okay, so this is where we set our priorities. I'm going to pull up these guys like so. Okay, so here's our two links. So what you're going to see here is that we're favoring the Fiber 24, right? We want the router dead interval to be a little bit lower. So I'm going to make it 15, okay? And I'm going to actually make the hello interval a little bit higher because we've got two links here, okay? Now, why am I doing this? Because I want this to fail quickly if there's a fault in the connection, and I want it to take longer for it to move back over to that connection. Ugh, it won't let me do that. Of course, duh, that's right. So we'll do the hello interval at 10, and we'll do the router dead interval at 10. Can we do that? Will you let me do that? There There we go. Actually, I want it to be 20, but it won't let me do that. Here you go. All right, is that good? Yes, because I'm sure that would cause some flappy flap, right? All right, apply. Really? Routed it must be larger than hello and it must be larger. Sorry, okay. There. Does that make you happy? There. All right, there. Are you happy now? Thank you. All right, so now the reason why I did this is because it's going to take 20 seconds before it'll start using, like before it'll create an adjacency between these two routers. But after 21 seconds, it'll cut the link completely. It'll just drop it. Okay, so it'll keep retrying for 21 seconds, and it'll, you know, it'll linger. Okay, so the idea here is you want this link to drop fast, but you want it to come up slow. Why do you want it to come up so slow, you might ask? Well, let's say that you've got a band of rain squalls coming through, right? What can actually happen is that during the heavy rain, right, you'll get little bands of clearing. But if the link is like up and down like a yo-yo fast, and all the traffic is like bouncing across that link, what'll end up happening is that the customers will see like consistent ups and downs, right? And they might even see consistent drops or packet fragmentation or packet loss, and you don't want that. You want the network to be as stable as possible. So by waiting until the AirFiber 24 here or whatever sensitive radio becomes stable again first, you're ensuring your network's going to be very efficient. Okay, so the hello and dead interval now aren't nearly as important on the failover. So we can pretty much leave them default if we want. Why? Because we're talking about a link that we know is going to be stable most of the time. I say most of the time. I'm making finger quotes here, but you can't see me. I'm going to have to like do a video clip of me doing finger quotes that Yuya can toss into the top corner of the video. Finger quotes. But anyway, I digress. The whole concept here is that this link should not fail. Most of the time it should be up. As you know, no equipment's 100% perfect. Sometimes you have a downtime because, I don't know, a snake chews through a cable, or a rat dies in an interface or something like that, or like maybe like some person who's missing all of their teeth due to poor life choices has gone and stolen all the cable off of your tower. You know, either way, one of those circumstances may lead your link to go down, but this otherwise may not go down. So we can pretty much leave it right where it is, because realistically, this is what affects this particular link, the B5 link, okay? So it should be remaining up most of the time. Now, if you want, you can actually change the parameters on this, you know, to tweak it up a little bit, but realistically, the AirFiber 24 is the one that concerns us. We want it to be a little bit more sensitive. We want it to fail sooner, and we want it to wait longer before it starts utilizing that link again. And that's kind of how we do that. And I'm not going to get into BFD today, as I am studying BFD to the fullest extent before I actually start demonstrating it to you guys, okay? So that's pretty much the explanation here. I'm going to do another video on how to do failover and load balancing over a bridged link, so where you can bridge two devices. And I'm going to do one with bonding too, because realistically, I think, you know, doing a bonded point-to-point link is kind of a stupid idea. Sue me. I don't know. It just seems like a stupid idea. And doing failover with a layer 2, like bridged networks, nobody should be running a bridged network if you're running wireless distributed networks. It should all be routed, okay? So, but I'm still going to do those videos anyway, because they've been asked for and it kind of needs to be done. So I'm going to do that for you guys. All right, but anyway, we have reached the end of this video at, let's see here, before the time cut, it is 18:33. So once again, thanks to all the Patreons who make this possible. You guys are helping to pay for the video editing and helping to well, feed me as well, because I'm working on a single income and living here right now. So, and I appreciate all the attention and love. Don't forget to like and subscribe. And Yuya should be posting a little list of all the Patreons who help make this channel possible. So thanks a lot, guys. Don't forget to like and subscribe and check me out on Patreon. All right, enjoy. Oh, and one last point I need to make. Don't you love my ADHD mind? It's just horrendous. Leave in the comments below anything that you want to see. Do you have questions about specific things that you've been struggling with that you want to see happen? Okay, and I will make a video discussing this if it's something that it should be made into a video. Okay? Anyway, catch you later. Love you guys. Bye.